Uh, okay, robot lady. So welcome to my seminar on organizing your research and your teaching material with Git. And of course, since this is a user group, I highlighted R, but I want to make the point that it Git works with other tools because, well, sometimes you're in a work project and it doesn't involve using R. You still can and probably should use R in those cases. So yeah, my name is Valdir. Thank you for the introduction button and everybody. Um, we got I want to promote here that our Akbe UIO GitHub page and also my own page, which you can visit and like smash that follow button, as the kids say nowadays. So anyway, getting some ground rules of the way. The slides will be made available on our page, public slides. I will show you the link afterwards. It's licensed under Creative Commons, so you can copy and use it whatever you want. Just follow some simple be nice rules. About this presentation, feel free to interrupt me if you have any questions or comments at any time. Um, we got the organizers checking up on the chat and everybody, so I will know hopefully if you write something or if you have a question. And I might post some stuff on chat, on the chat window, maybe links and everything. And we asked you to install Git on your computer. Like, this is not a workshop. This is more like a hands-on seminar. So we don't have time to help a lot if you have installation or usage problems. But if you can follow along by typing the commands that I'm going to show you, that's like even better. If you can't, that's still good. You can have fun just watching and taking notes. So let's get started to see what Git is and what isn't. And this kind of reminds me of school. Like, remember those presentations where people would start by saying, oh, the Merriam-Webster or the Oxford Dictionary defines Git as blah, blah, blah. And apparently, Git is not a very nice word, even if you look at the manual for Git. It's it's got a pretty dry sense of humor, the author. So anyway, this is just a small piece of trivia for you guys. And uh, but ooh, I got a problem here. So, well, give me 1 second, okay? You
No
can see my
problem.
screen again, right? All right. So what is Git? Now you can continue. Well, Git is a version control system, first and foremost, created like 15 years ago by this Finn called Linus Torvalds. He's of Linux fame. Nowadays, it's maintained by a group led by Junio Hamano. And this is the part where I wanted to thank Henrik for pointing me to this article here from Pikett and Brandmeier. So, wrong pen. Which says where they say that Git is at the base of a reproducible workflow, which starts with R Markdown, of course, basically talking about R here. Then we use Git to control versions, make dependencies, and Docker basically to package the whole thing. But I'm not going to get into details about this. And finally, Git is super good at handling pure text files. So if you work with R, Python, MATLAB, Stata, basically doing data analysis, as long as you're not working with Excel, and maybe even Excel if you're doing VBA, you can put those files in Git. Git is very good at handling them. And like I said, not only to do data analysis, not only to create software, if you write documents, if you're writing a paper, if you're writing a presentation, if you're just taking notes, then Git is also very good for handling those things. And on the other hand, what Git is not, that's also important to tell. Well, it's just not just for software developers. So I keep talking about this. Like if you're if you a researcher and you write no more than just a few scripts to do data analysis, you can and probably still should use Git to control the versions of your files of your software. Uh, Git is not a very good place to dump large files because of the way it's structured. Unlike other version control systems, Git basically saves a full copy of your files to kind of oversimplify it. So your repository can get very, very large, uh, pretty easy. Although GitHub may be like an exception because if you're like me, like many people use GitHub as like a file hosting page. And also I skipped this point. So files that are generated from other files. So if you work with LaTeX, so you generally in the end generate a PDF from a text file or from your R Markdown file. Maybe this file should not be on Git. These should. And while I'm talking about GitHub, this is like a point that I really like to make because it's a bit of a pet peeve of mine because every Git course I see just talks about Git for 5 minutes and then starts talking about GitHub. So I really like to highlight the fact that Git is not the same thing as GitHub. GitHub basically focus on the distributed workflow feature of Git, but that's like a secondary thing. The main job of Git is to do version control, collaborating on software, collaborating on files, whatever the purpose. It's like a secondary thing, and that's where like GitHub shines. So now really a last chance to install Git. If you're doesn't matter if you're on Linux, on Mac OS, on Windows, you have like instructions here. They are all summarized on the download page. So this was your last warning. If you haven't, we are soon gonna start doing some typing. One slide here to tell you that Git is basically a text-based software. Don't be worried. R is also basically text-based, and the reason for that is that it's really good if you're looking for speed. Text-based, non-graphical stuff are really fast, and also if you use your keyboard a lot, which is faster than using your mouse, that's really good for base Git, just like base R. Let's talk about like the basic thing. And it's not so great if you like to use your mouse and you don't really care about speed. But even if you identify with the latter, you can still use Git, of course, just like you can still use R. There are graphical interfaces for R, like RStudio, and the same way there are graphical interfaces for Git. I'm gonna talk about three here. The first one is really, I guess, popular and known among RStudio users because RStudio has a built-in GUI. So it's pretty convenient if you only use RStudio, but at least last time I checked, it's been a few years since I last used RStudio. It's last time I checked, it was pretty limited in features, and it's prone to freezing, especially if you have large files or many files. Second up, there is a Visual Studio Code. It has a built-in GUI, and it also has some extensions, for example, Git Graph and an R extension if you're using R, of course. And the reason I'm talking about Visual Studio Code here is basically twofold. One is that I want to remind you that RStudio is not the only thing and not necessarily the best one to work with R. And also there's something called GitHub Code Spaces now, which is like in beta. And I'm kind of biting myself here for talking about GitHub again, but this is real quick because if you use a lot of Git, then eventually you're going to, I guess, use every now and again GitHub, especially in academia. And GitHub Code Spaces basically allow you to use VS Code inside of your browser for free and everything. And to put up um, a bad side of it, VS Code doesn't do a very good job of handling pulls and merge conflicts. We're going to talk about them a little later, unless you install more extensions. But anyway. And finally, there's Gitkraken, which used to be my favorite tool. It's very robust. It's full of features, and it's the one we're going to use for this talk. Apart from the terminal, because I still want to show some terminal stuff because it's like as universal as I can make this. And the downside of using Gitkraken is that it's basically adding another app to your workflow. If you use RStudio, then you would have to use RStudio for your coding, and then Gitkraken with the for the to handle your repository. Same thing with VS Code, and that's kind of a handful, I would guess.
So can I ask a question?
Yes.
So the GUI I'm most familiar with, and I think it's probably the one that's most mentioned if you start Googling this, is GitHub Desktop. Do you have any opinions on that? And just because it seems to be so commonly used, I'm curious as to what you were thinking about that.
Yeah, that's a good point also, because that's like the official one. I don't know. I always forget about that one because I always start to use it and then I find it a bit lacking. But anyway, you should use whatever you think is like whatever works best for you. And I guess if that means using like the official one for GitHub, if you use Git alongside GitHub a lot, then maybe it's a pretty good choice.
Do you think, did you start with command line or with a GUI?
Yeah, I
And
started
if
with the
so,
command
did you
line.
find it, do you recommend going that route if you're not too comfortable?
Oh yeah, well I'm a big fan of using my keyboard for everything. So just like uh, when you, I guess when many people when they first start using R, they discover they get over that hill of, oh, I was using Excel for everything and it's very practical because you're clicking and you're moving your mouse around, and maybe R starts looks a bit daunting at first for that, but eventually you get over it and you get used to it and you start noticing that it's faster to type things. So that's what happened with me with Git, except I jumped straight to the terminal, and I also use like a GUI for, because sometimes I'm lazy, I'm just working with my hand on the mouse, and I'm not doing much typing, so I use a GUI for that. But I still use the terminal a lot, maybe even more than a GUI, because it's much easier to type.
Okay, cool.
I
I was just
think.
curious as to your perspective. So.
Yeah. So yeah, moving on to some lingo. Uh, we're going to talk about three things here, three important. One is the repository, or repo for short. That's basically a collection of past and present versions of your working directory, so the folder you see on your computer. Locally, your repository is a hidden .git folder in your working directory, but it may also be hosted online, like on GitHub or GitLab, Bitbucket. I think that still exists. Anyway, that's your repository. So you will probably always have a local repository, and then sometimes also an online repository. Number two is the commit. So that's a particular version or a snapshot of your working directory. So if you think, you can think of a repository as like a collection of commits. And your basic workflow would be to, work on your files. Then you save and you press Control S as much as you want. And when you want to to use the word. When you want to commit to a version of your files, then you create a commit. And whatever you saved and deleted in between saves, that doesn't matter. That gets ignored. So it's not like Dropbox where anytime you press Control S, it saves a new version. So if you're nervous like me and you keep pressing Control S after typing 2 words, it becomes basically useless. And third, hash. It's basically a 40 character alphanumeric identifier of a commit. So every commit has like a code, has an identity that's called the hash. So it's usually pretty long, but we often use like a shortened version of it. Usually more than the first 6 characters that's usually more than enough. And in any case, you don't need to worry. You're not gonna need to know them by heart. They will always be visible for you on the log. We're going to talk about this a bit later. So where on Git are your files? They basically exist on three separate things. One is your working directory. So that's where your files always are if you don't use Git. That's like your hard drive, that's your computer, that's the folder where you do your work. And your goal is to basically commit your files to the repository, right? So you would use git commit, which is the name of the command, to put a certain version of your files on this repository. But you can see there's actually an intermediate step here, which is called the staging area. So what you do is when you want to commit, by default, you use git add to put your files like in a temporary staging area so you can take a breather and look at your files and make sure that that's what you want to commit. And after you add all the files and you're really ready to commit, then you use git commit to create a new version. And one last thing before we start working, I would like to propose you organize your workspace if you have the real estate for it, if your screen is not super tiny, and you want to follow along by using Git yourself, then this is one way you can do it. You can put these slides like on one quadrant, then maybe the Zoom chat or some text editor, some notes here at the bottom. Then I would like you to have one space for your file explorer where you're going to see the files from your project, from the project we're going to create here. And then finally, like your favorite Git interface. Doesn't I don't care if that's a terminal or VSE or Studio, Git Kraken, whatever. So this is also kind of how I've organized myself here, except I don't have the notes. Uh, and the reason for this is that this is good because you don't get any window overlapping mass, and so you can see, and you can see everything as it happens. Like you can see your files changing, and I think it's better for understanding the whole process. Okay, so finally we're starting with some Git commands. Now we're starting to work like half an hour in, so not so bad for someone who didn't practice. Okay, so assuming you installed Git, the first thing you do is configure your user info. So you go to your terminal, like it doesn't matter where you are on your terminal, you just write git config, and then you can put global, or you can just not do two dashes, not do global for like setting this just for this repository, and then you put your name. Sorry, config. See, that's how you do it. Oh yeah. So actually, the first thing you do is type git init to initialize a repository on your local thing. If you do the global thing, then you don't need to initialize it first. Can you actually see this? Maybe I should make it larger. Is this better? But
maybe a bit larger.
Okay.
Yeah, excellent.
All right. So if you do the global thing, you don't need to initialize a repository. But since I'm doing it locally, then I used git init to initialize a repository. And then you can configure your username and your user email to uh, to get it set up. This matters. So when you do commits, then they get in lingo in Git jargon, they get blamed on you. And yeah, and the reason one of the reasons I did this on the terminal is that when you do this, at least on Git Kraken, it starts like a README file. It's pretty annoying. So we're gonna get to the GUI in a while. So anyway, now we are set up for work. Assuming like this is my file explorer, so this is where I will host my project. And okay, so next step is starting to work. So we are off to do some science, and then we're going to commit, or which means registering on Git a version of such science. So let's say you just create a new file here, and maybe data analysis.r, and yeah, let's open this and oof, I don't know, read CSV. Let's try to do it properly. So data.csv saved, and okay, so I just saved something on my working directory. So if we come back here to our terminal and we write git status, now we see here, okay, on branch master, no commits yet. And there is an untracked file here called dataanalysis.r. So, and it's pretty clear on the instructions. Use git add to include what will be committed. So let's do that. So git add, let's say we want to commit something. So we do git add dataanalysis.r. Now we check the status again and see it changed. It says changes to be committed. So it's in the staging area. You can see you can use this command to remove it from the staging area. And it says, okay, there's a new file called dataanalysis.r. Great. So let's commit this. So let's do git commit. And I'm going to take a step further here and put this dash m so you can already write the message inline. Otherwise, it's going to open a new window for you to write your message. So I don't know, imported CSV.
Valder, just a quick question. Is it possible for you to increase the font in your terminal?
Yeah.
Thank you.
Good enough?
Yeah, for me it's perfect.
Okay.
Yeah, cool.
Come on. I got another version of myself here on the phone. I can read it on my phone, and my vision is not very good. Anyway, if you need it even larger, just let me know. So okay, so we just committed a new version, and what do we do now? Let's see what we got with git log. So now it just says, okay, so this is why you configure a username. You configure a username because then you can know who did what, when, and what they did. And this is why it's important to like write meaningful commit messages, because if you just write uploaded this, updated that, then it's gonna come back and haunt you. So this is basically what we did here. We used git status, we added a file, we committed it with a message, and we checked the log. So maybe now it's a good time to show you on Git Kraken. At least let's start, or let's open a repo since we already created it. We have one on the temp directory. So there you go. So this, I assume, is too small. So I think this is as large a font as I can get on Gitkraken. But anyway, what you see here is basically your repository temp and the branch you're in. And this is your commit here. This is the message, imported CSV. You can even see part of the hash here. You could also see the hash here. Oh yeah, forgot to show you. This is the commit hash. And so yeah, so this step is done. Let's move on to the next step. Let's do some more science. By the way, this is how you're probably looking now if you drank as much coffee as Jim did on the other slide. So let's keep adding and editing the file. Let's write a summary of the data of the DF. And yeah, it's a typo, I know. So okay, so I just saved, I just pressed Control S here, and I'm doing a summary of the data. Let's go back to the terminal. Let me clean this up and do a git status and see what we got. So it just said modified data analysis.r. But what exactly happened? For this, you can use git diff. And then it says, okay, I added a row here with this. If you delete it, then there would be like a minus sign here. And just to show you on what's happening on Gitkraken, it shows up here like one file change in the working directory. And then you can click to view the change. And then you see here data analysis.r. And you see it's much nicer looking. You can see exactly what was added. So this is also another advantage of a GUI. And we can commit again. Actually, I'm going to do this commit on the GUI just so you can see it on a different place. So let's stage the file. This is the same as doing git stage. I just clicked here on the right corner. And now you see it shows up on the stage files. You can unstage them easily by clicking here. And here's where you actually do the commit, where you write the message. And finally, you click here to like commit your commit. Ha. So the summary of data. And yeah, no need for description. Let's commit it. And now we have a new commit here. We have two. This is the second one. And same thing here on the terminal. If we do git log, then we see the second one here. So the head shows where you're currently, where your working directory currently is. And if you want something a bit more similar to what you have on the GUI, there is this option. You can write git log graph. Oh, that's a weird spelling. Graph, and then you got the little line connecting the dots. And I think you can do format age or something. No, that would just show you the. Anyway, I'm not gonna look for it. There is another command to simplify this. But anyway, that's actually answering or going back to the question. This is mostly what I use the GUI for, like looking at the tree, because I like looking at my project Git trees. Also because they can get pretty complicated, especially when you have many collaborators. So yeah, so we just did a little bit more science. Let's do one more here. Let's create a paper. And yeah, so out of habit, I created it as a tech file. So let's say woo. let's just write a basic article. And yeah, same thing. Git status. It just has an untracked file. So git add paper.tech and git commit added a paper, like added paper file. So you check our log again, and now we have 3 commits already. Okay, so this is the very, very basics. Let's take it up a notch and start talking about undoing changes. So let's say you add something else. Let's say you are working on this file and you add some silly work. So here, I just saved it. I pressed Ctrl S. Sorry, I told you it's a very big habit I have. I don't even notice when I press Ctrl S. So if we do git status, we see what was modified in our data analysis. Let me just remove one line here. Let's remove the summary line, just to show you what happens when you remove. That's actually for a git diff. So you see it removed this line and it added this line. But let's say we kind of regret doing all this. So how do we come back to the way it was on the commit? We just do git reset. Actually, it's using git restore. So we can use git restore or git reset on this case. So if we do git reset, what's the name of the file? Data analysis. So it unstaged, and you can see here, I shouldn't stop point with my finger. So you can see here, the file went immediately back to the way it was. Actually, it didn't go back to the way it was on the commit. For this, we would need to do git reset, and then maybe this is the hash for the last commit, A8D9B6. A8D9B6. And what's wrong? Well, oh yeah, I guess I have to do like a hard reset. Yeah, and I had to just close and reopen my file for some reason. So I did a reset here on this commit, and now the file is back at what it was before. So let's see. So you should always do like a soft reset in the beginning. And if that doesn't work, you should try hard resetting, but beware that you are going to lose the changes you've made thereafter. So let's fix this. Let's do summary instead. And to show you another trick, if we do git status here, it says that it modified data analysis. Git diff shows you that we replaced this line with this line. There are some options you can change. For example, this is like a custom option that I created. So this will probably not work for you. It's just an alias I created just to show you when 2 lines change. It can show you the change on the same line. But since this file has already been committed in the past, you can do a git commit directly using am, or just using a, and then I'm putting m for the message. So fixed typo, and this is our log. By the way, since we're talking about aliases, I also created this git lg, which this is what I wanted to show you earlier. I just don't know anymore how to do this without using the shortcut I created. So this is another way to look at your log, which is much nicer when you have a long log. Uh, well, anyway, so if you want to, you can also take a look at a log of just one file. For instance, you can do git log of your data analysis file. Then you can see exactly just what happened with this file. Oops, this is not the end. So we started with this commit, then we did this, then we did this, and this is basically the whole history of this file. You can also do this on here on Git-Kraken. If you click on the file and you click on file history, then you can basically see the same thing, except you get to click around with your mouse and see exactly what you did, when, and who did it also. And finally, so you can, oh yeah, no, actually let me show you these also. You can also not only see the versions of your file, like here on Git-Kraken, it's pretty straightforward. Whenever you click it, you see like the whole file. Actually, it's just showing here diff view, so it just shows the difference. The thing is that our file is so small that it doesn't matter. But you can click on file view so you can see the whole file and the history of it. Whereas on the terminal, you would do, I forgot, git show, of course, yes. So let's say I want to see how the file looked here. I'm going to do git show, not shot, the commit, the hash, and then the file, data analysis.r. So it shows you exactly what you had on that file. Then also, of course, there was only one line, so let's try to do something else. So this was the file then. And then you can also save this somewhere else. Let's say the first version of your file, you want to save it to your working directory. So you just use this greater than sign, and then you write file.r. Let's do file old.r. So when we come back here to our directory, now we got like the new file and the old file, the first version. And now you can get to play around with it in however you want. So let me just remove this. And tagging, of course, you can tag a commit. So for instance, let's go back to our paper and let's say you finished it. So author, me and him and her, begin document. This is my paper ready for publication. Yeah. And oops, close this. So that's your paper and it's ready for publication. So let's do a commit here on Git-Kraken. We stage the file and finished paper for publication, for actually for submission, not for publication. Okay, so new commit, new thing. You can add a tag by right-clicking here and creating a tag. Let's do it the hardcore way though, which is not so hard. Just do git tag, and then let's say this is the one you submitted to your journal. I think you don't even need the quotation marks. Yes. So git log. This is, it doesn't show you your, oh no, yeah, it does. Here it is. This is your tag now, submitted to the journal. And this doesn't follow the head. if you move the head somewhere else, as we're going to see, you will next up, you will see that the tag is attached to this commit, so the tag stays here. Okay, coming up next is Git's greatest strength, in my opinion. Oh, this is the wrong window. Make start. No, this is from something else. Okay. Okay, Git's greatest strength, in my opinion. So if you think about Git as like a tree, um, think of your, like the trunk of your tree as a repository, or actually the whole tree as a repository. You can think of your files as leaves attached to some branch of this tree. Okay? And the thing about Git is that it allows you to have different parallel running versions of the same file on different branches. And this is kind of where the analogy falls apart, because you should expect your branches to merge back with the trunk eventually on Git. That's like the happy scenario. And so kind of recapping here. So the parallel versions of your files are the different branches, which conveniently are also named branches on Git. So files, the files, they start the same, but they differ after some commits. And the goal is to merge back into your trunk with the trunk of your repository. So this is what we're going to do now. We're going to create a branch. We're going to check it out, which means switching to the branch. So you do this with git branch and then the branch name, and then git checkout and then the branch name. And actually, we're going to do some work then, and eventually we're going to merge that back with the master branch. Actually, here I go, talk about GitHub again. GitHub now has the main branch. It's not master anymore, it's main, so that may be important to keep in mind for new repositories anyway. So yeah, so what we would do is, you can do like git branches, no, git branch here to see what branches you have. And for now, you only have the master branch. So one thing you can do is git branch to create your new branch, and then write, I don't know, new stuff. And then what you can see here, maybe I can get rid of, nah, whatever. So you see here on GitKraken, you see the master branch and the new stuff branch. They're exactly at the same spot. And here's your tag, by the way. Also, if you do your git log, then you see your master, and the head is on the master. So this is what you see on your computer right now. And we got another branch here called new stuff. So what happens when you check out that branch? You can do it on GitKraken just by clicking with your mouse, check out new stuff, or you can do it the hard way. It's not so hard. So I forgot, git check out new stuff. So it says it switched to branch new stuff. If you do a git log now, you see that the head is on new stuff. Doesn't really matter because at this point, because you haven't changed anything on your files. But there it is. So let's check out master again and delete the branch, git branch d new stuff, because I want to show you something else. You can do straight git checkout and then d, and then you give your, so this is basically doing git branch, creating the branch and checking out the branch at the same time. So let's say you're working on, I was going to say new stuff again. So new things. So you see it already switched to a new branch called new things. You see the head is on new things. So let's imagine that you have done more analysis, or so you wrote like you fit like a model, or I don't know, y based on x for your data. And so this is like a new model. Let's say you also, no, actually, let's commit this. So back here to the terminal, git commit am data analysis, added the regression model. So yeah, sorry. When you do am, you don't need to mention the files because it's already doing on all the files. This is actually something important to mention, because when you do git am, you're basically adding everything. Also, by the way, this is an important, useful thing. If you don't want to do git add and then the name of the file, especially if you have many files, you just do git add dash capital A, then it adds everything. So if you check the status again, it's ready. It's in the staging area. So git commit m, and added regression model. So now let's check the log. Let's do a little graph. Now you can see how the head has moved with our new things, and we added the regression model. The master stayed back here and your tag stayed back here. So, and so we're not gonna merge, not yet, but let's say in the meantime, your paper came back, and naturally your the reviewers want something changed, of course, so you're going to change it. So we open our document, and we address the comments from the reviewers. Yes. So we save the file, and now I actually made one mistake here, which I often do, but it's not a problem until you commit. You see, I'm on the new things, but the thing is that this is not the version that was sent to the journal. It was the version on the master branch. So what we do is we should check out the master branch. So we should go back to the master branch, and I think something interesting is going to happen here. Check out our master. So it switched to master. And yeah, so if we do git status, you see that our changes are still there because they weren't discarded when we did the checkout. So now we're on master, and let's say we added a little bit more things. Let's edit this line 4. I'm editing the line we had before, kind of on purpose, to create a conflict here. So, but we added a tiny thing here too. So yeah, so if you check, you see you're in master. Let's create a commit here. So you can see on Git Kraken that it explicitly put, I hope you can see this is like a lighter shade of green, because it just saying that this was the text that was added. Let's state this change and commit. Address the reviewer. Oh boy.
Is there any chance you could increase the font on this screen?
Sorry, unfortunately, I think this is as large as it gets. I can make it smaller, but when I press, oh, wrong button. When I press Control plus, it doesn't go any further than this. I'm sorry.
Oh, well. Okay, but there's a question from the chat. Can you
Yes.
clarify what or when the clone is used for? I have no idea which directory to use.
Yeah, we're gonna get there, like if in the end, if we have time, but maybe to get a little bit ahead of myself. It's mostly used when you have a remote repository. For example, you have a repository on GitHub and you want to create a copy of it because you want to work on it on your computer. So you use git clone and then the address of the remote repository. Then it creates a copy of that repository. And then you change and commit, and everything you do is going to be on your local repository, on your Git folder on your computer. And then when you want to move those changes back into the remote repository, then you use git push. And then when you're working on it for a second time, you use git pull to basically do kind of like what cloning does, but like to update. But anyway, git clone is basically when you're working for the first time and you want to copy something from the internet. Okay.
Yeah, cool. Thanks.
Okay, so let's commit these changes from the reviewers' comments. All right, see what happened here? We just created a rift in space time or whatever. So we got a version here on master that is like ahead of our new things because we did the last commit there, but it's not the same thing. It's a branch, or actually technically the new things is the one branching out from master, but that changes. Git is not very consistent with it. If, for example, if we check out new things, sometimes it will switch back. But anyway, on the terminal, this will look like, oh yeah, sorry, we have to do git all. So we see the same thing here. We got our head on the master addressing the reviewers' comments, and then we got some new things, our new things branch down here. Okay, so let's say we still want to add our new things because that's allowed, right? Usually. Maybe you want to submit this version already. Oh, it made a mess here. Let me clean the screen. Maybe this is the version you want to resubmit, but let's say that you want to also add your regression model to your new submission. And then, of course, you want to write about your regression model on your paper. So let's check out the new things branch. So we switched to it, and hello. Yeah. So this is like our paper. Yeah, for some reason Vim doesn't like to update the file. So this is how things are on the new things branch. You see the original paper. You see your data analysis with your model, right? If you switch back to master, I'm double clicking here on the master, then your data analysis has no model because you didn't submit a model. So we check out new things. We're on new things. We got our model here. And we open our paper and we are going to talk about our model. So we add a new section. This model is pretty good. And we save and we commit. AM is just committing everything that that needs to be committed. In this case, it's just the paper. Or let's add another file. I just want to add a comment. Add some comments. Control S, close the file. So if we do our git status here, just to show you, there can be more than one file here. And when we do git commit am, you're committing everything, and you're just basically saying ready for a new submission, or this is a bad message. So added regression to paper and commented on R, whatever. Okay, 2 files changed, 3 inserted lines, 1 deleted line. This is useful. And now we go back to our log. Oh, actually, let's do it here since the font is larger. Git log graph all. So we see now new things is the head. That's what we're working at. It's ahead of master. Master is back here, and our submitted to journal is still here. So we're basically 2 commits ahead of master. So now it's time for a new submission. So let's clean things up. Let's go to check out the master branch. So switch to master. You can see here data analysis is nothing. It has only a summary. The paper though has like the comments you addressed. So it's time to merge. So on Git Kraken, on a GUI, you usually just right click here and where is it? Merge new things into master. But let's learn. We do git merge, and then we basically would do git merge with our new things branch. If you do this, usually if it's like a very straightforward merge, if there are like no problems whatsoever, then it does what is called fast forward merge. But one thing that is often considered best practice is to add a -- no ff switch, so it doesn't do a fast forward. It always asks you to do something. I mean, it always shows you on it will show you on the history, on the tree. It will show that this branching out existed, because if it does like a fast forward branch, I can show it later, this branch disappears. It only becomes like one straight line if it can. But what's going to happen here if we try to do this git merge? Look what happened. So there's a conflict in paper.text. Yeah, so it didn't do an automatic merge. We should fix conflicts and then commit the result. So what happened here in practice? So you see, actually it only complained about paper.text because the data analysis is fine. You see, it just added this line here, so there were no conflicts here. Now let's see our paper file. Look at this. So it's suddenly like an ugly thing. And what we have here, oh yeah, I should have done this before. So what we have here is that basically Git throws its hands up in the air and says, I don't know how to solve this conflict. So you deal with it. So you see the file is here, and what it did was split what is in its head. So the lines that are conflicted are here and here, split by this line. And this can happen on several points in the document. So this is like one conflict. This is what's on the head, on master in this case, and this is what's on the new things branch. So it's basically up to you. You can, like the old school way would be to edit this document. This is a regular text document still. So you can just edit and then remove this and then remove this, and anyway, adjust it however you want. There are some tools also to do this on the terminal. But frankly, for these conflicts, I usually use a GUI because it's easier to see what you're doing, because you have to be very careful when you do these things, especially on complex projects, because you can end up sometimes choosing to keep the thing that you were supposed to drop. So you see here that we tried to merge, and Git didn't merge, so because it found a file conflict. And we can view the conflict by clicking here. So let's click here, paper tech. So again, you see the two versions here, and you can choose to pick one of them. So you see the output will be this, or you can choose both. So the output will be this, or of course you can add it yourself. Like, okay, this line is old, and this line I'll keep, and okay, this is how I want my final document to look. So we save these changes. This is basically just like saving. If you would do it, we're doing this on Notepad or whatever, wherever you want. This is just a text editor at this point. So you see, it came here to a resolved files. This was basically, it had a different name here. It was like working directory, staging area, or something. And now it says conflicted files, resolved files. So everything is resolved, and we're ready to commit. So let's say conflicts with master, and commit and merge. So now you see it merged back with the trunk. This is so nice. This is perfect. So if we go back to the terminal and we see our tree, no, graph, then you see the same story here. So it branched out, and eventually it merged back with master. So now we're back on master, and our new things branch is back here. And we frankly don't need it anymore. So it's usually good practice to just delete this. So you see what, yes, thanks. So you see what you're deleting here. This may look like a dangerous thing, but what you're deleting here is just the pointer. It's just the branch name. So it says here, new things was here, 1FF77, whatever. But you can see on the graph, your things are still here. Whatever you did with the branch is still logged. So you didn't lose history here. You just deleted the pointer. So yeah, so we're back into master, and we're ready to submit again. Let's say you submit this. So let's add a tag. We submit it, and that's it. That's a small project that you have.
Is this a good time to take a short break, Walter?
Yes.
Or how much
sure.
left? What's your timeline?
I'm like on slide 22 of 28, so it's just tiny things. Like the big Git things are over.
Okay, then I suggest we power through and don't take a break.
All right. Okay. So next up, talking about a file called git ignore, or git ignore, if you've made the same mistake I made and found this thing online. And sorry about that. I'm not going to suffer by myself. So anyway, there is something called a git ignore file, which is very important, because remember when I said earlier that you shouldn't keep everything on Git. So you should let Git ignore some things, mainly data sets, literature, files generated from other files like our PDFs and whatnot, and some files that will never change. So the way you do it is basically creating a file called .gitignore, and just put all that in. For example, here we have uh, this was generated. I think this is generated from GitHub. So this is a project that started on GitHub. So this is the content of gitignore. So you have some silly files, our history, our data. Who cares about whatever you saved temporarily? These are all temporary things that R creates. Um, there are some directories here. Everything that ends with a slash is a folder. So who else cares about your R project user folder or your vignettes? It's usually you shouldn't keep like the generated files because the vignette is usually generated from like an RMD file, for example. So you should have this on Git. You shouldn't have these on Git. Otherwise, you're just creating copies of things you can generate from the source code. And yeah, that's basically it on the example. So kind of when somebody asked about git clone, I was going to save this for the lightning round because I didn't know if we would have time. Do we have time to talk a little bit about these things?
Yeah, sure.
Yeah, this is going to be quick anyway because I'm not going to do any cloning from GitHub. But basically, the idea is that you use git clone and then some address to create a local copy of a remote repository, and then you can do if you already have cloned that repository and you're coming back to it a second time, you use git pull. So you basically update your repository to actually you should do git fetch before. No, like, oh yeah, this. So in between here, it's usually it's a very good idea to do git fetch p for prune, so it removes things that don't exist anymore. This will make sure you're seeing the latest version of the remote repository. Then you do git pull to sync your branches with the remote branches. Then you do your work. You do your commits, you do your branching and pulling and whatever. And then finally, when you're done, then you push just the let's say the master branch or whatever branch you're currently working on to remote. And talking about stashing and popping, this is a useful thing because sometimes Git will refuse to change branches, especially if it's going to create, it knows it's going to create a conflict because it only tries to resolve conflicts when it's merging. If um, if it doesn't, then we have to use these. And this is a pretty simple thing. I'm glad I have time to demo this. Let's say, yeah, let's work on our paper again. I have to make this large again. So let's say we create a new branch, git checkout, crazy idea. And we start doing some, actually let's keep it with the theme, right? This is an R group. So actually I think this font should be larger.
If possible, yeah.
Is it? Well, too late. Now I
Yeah.
got my hands on it. Okay, so let's add our crazy idea. So let's say we don't need this, and then we add some crazy idea, added crazy stuff. Sorry, this is barely readable. Even I can't read this comment. And this data changed, data chew. Let's just create a mess here and x plus x square. So Okay, so I just saved, and let's commit this. Git status. Let's see our diff actually. So we changed nearly everything on, on this branch. Tested, crazy idea. Oh, sorry. I wasn't supposed to commit. So this is a good. Actually, I'm gonna show this on the GUI this time around. I didn't want to commit this because this is just a crazy idea. So let's click here and where is our revert? Here. Let's revert our commit or reset our crazy idea to this commit here in master. And here you see the options. We can do the soft one where we keep all the changes, the mixed, or the hard, which discards all changes. So let's keep all the changes this time around. So you see we're back to the crazy idea. Our files are staged again. So let's unstage the files, and here we can see our crazy stuff. But let's say for some other reason, for some reason, we decide we want to go back to master. We don't have time to work on the crazy idea right now, or maybe your colleague showed up and you want to show him something on master. So we want to check out master. It switched to master. Why did it switch to master without any problems? Maybe I need to commit. I'm trying to force a conflict here. Implemented crazy idea. Okay, so now we have committed, and we can see here that the crazy idea is committed. And now let's actually change this again. So we add more comments. We change this name to fit. And I think that's enough. So I'll close this file. So you see, this time I'm not gonna commit the changes. And now we have a crazy idea branch, which is different from master. So hopefully it will complain now. Check out master. Okay, see, finally. Error, your local changes to the following files would be overwritten by checkout. See, this is the trick. So it's not gonna try to resolve the conflicts or anything. So it says there are some problems on dataanalysis.r. Please commit your changes or stash them before you switch branches. So let's say we don't want to commit the changes this time because we just don't wanna. It's just like a small thing that we changed. So what we do is use git stash, and we can write it just like this, git stash, or we can put a little message like unfinished changes. Or I should put an M here. Okay. So it saved your working directory and index stage on this crazy idea unfinished changes. Let's see how it looks on the log. It looks pretty fine, actually. Do I need to do all? Yeah. So if you do git log with the all switch, then you can see your crazy idea. Then it has like an index here. Don't really worry about it. And then you have your stash with your changes here. And the way it looks on a GUI would be, it usually shows like, oh yeah, this is it. So this tiny thing here and finish changes, this is our stash. And now we can check out with check out master. Third time's the charm. So we check out master, we go to our data analysis, we see it's very clean. It's the way it was. we show whatever we need to show to our colleague, or we do changes and we commit and whatever. And then when we come back to our crazy idea, we open the file, and what's going to happen? Well, nothing, because actually we have just the changes that we have committed. We don't have the things from our stash here. If we do the log, you can see the head is on the crazy idea. Whatever you saved on your stash is still there. You just don't see it. For you to see it, you have to do git pop. And I think I can just write git pop here. Sorry, git stash pop. Okay, so it did on branch crazy idea, and then it retrieved your changes, and then you are ready to commit. If you see the file here, then didn't I pop? So yeah, anyway, I'm a bit confused right now. But your changes are this is the thing that you added to your stash. It's only supposed to show now that you popped it, and then of course you can stage it and commit it. And let's say, ooh, why can't I write here? Anyway, I'm gonna write it here then. Okay, and I think this is as far as we're gonna go today. So to wrap it up, some supplementary material. Where can you learn more about Git? Well, the official documentation is pretty good. It's got like videos and text files. It's very, very well documented, very well curated. I really recommend getting there. Or if you Google whatever question you have, eventually you will end up either there on Stack Overflow. Of course, if you're on your terminal, you can always use like git help or man git, man for manual git. This will work on Linux and I think Mac OS. I'm not sure about Windows, but this has all you need to know about the options and Git. As you can see, it goes so much deeper than what we showed today, but you really don't need half the stuff that's here. I doubt. Just the basics are enough. And if you have any questions about some command, you can do, for example, to get questions on branch, you just do a -h, and it shows you all the options that you have. Right? For a git log, this can be pretty useful. Oh yeah, decorate. That's what I wanted to use before. Anyway. And oh yeah, so speaking of cheat sheets, yeah, I'm going to, when I share this, there's a link here to a cheat sheet, but that's basically me going to DuckDuckGo and writing git cheat sheet and looking at the results, because really it's that simple. Like, that's all you need to do. Oh, it even got like my typo. So you got a cheat sheet here. Okay, finally some references. This seminar was not really inspired, but this paper, as I said before, recommended to me by Hendrik, was really good. I learned a lot from it about the whole pipeline of Markdown, Git, Make, Docker. So it's a nice companion for, and it was a nice way to complement the seminar. Those operating system icons I got from Flat Icon, the lightning photo from some guy on Pexels, and What else? And yeah, that's it. I think I skipped. Yeah, I skipped a slide. Okay, there you go. I was confused. If you're wondering what software I used in this presentation, the slides were done on Markdown. I used VS Codium, which is like a telemetry free version of Visual Studio Code. So basically, Visual Studio Code without the Microsoft branding. So if you're, for example, the kind of person that prefers to use Codium instead of Google Chrome, sorry, Chromium instead of Google Chrome, then you were probably going to prefer using VS Codium and Git Kraken, which is a free Git GUI for Windows, Mac, and Linux. Okay, I'm tired. Thank you very much for listening to me.